domain of the sum, difference, and product and quotient functions consists of the x values that are in the domains of both of them. So if they have different domains, when you combine the functions, you just have to look at the domains that are in both of them. And then, of course, you have to also exclude any place where g of x equals 0. Okay? So just take just a second. This isn't going to be too hard. And see if you can find the function f plus g and the function f minus g. And then after you do, find their domains also of f plus g and f minus g. Okay, so that's what you get for f plus g. Okay, so when you guys look at this one, what is the domain? What can the x values be in f? What can you have the domain of f be? Is there anything f cannot have plugged into it? It's a parabola. Does it go all the way left and all the way right?
Yeah.
Okay, g is a line. Does it go all the way left and all the way right? So domain, all real numbers, negative infinity to positive infinity. So that's going to be the domain on both of them. It's just the combined wherever their domains overlap. And then, Sam, what did you get for f minus g?
I got, it was 2x squared minus x, and then it was plus 11. Yeah, plus 11.
Okay. So you'll have one problem. Actually, the one you have on subtract is a subtract one, but you have to get common denominators because it's a rational function. But you guys just got done doing that, so you should be good at that. And then an add one was an easy one that you have to do on your homework. Okay, do you guys, so just remember that when you have to multiply them, you just multiply them out, and when you have to divide them, what about the division one? So multiply, you just actually multiply it out, right? And you guys are all really good at multiplying that out. And it takes a second just because it's a trinomial times a binomial. When you divide it, just double check to see if anything will simplify. It may or may not, but now you guys have simplified. It might simplify. So it's going to be f of x divided by g of x, which may simplify. If it's going to simplify, I know that this has to be a factor, so just double check and see if that factors into that, because if not, it's not going to simplify, right? So if this were a factor, 3x plus 1 on the top, what would this first term have to be in order to get 3x squared? X, so I get 3x squared. And then if this is a 1, what does this have to be in order to go with that? Yeah, the last two have to multiply to negative 4.
12.
So negative 4. So
But
does it work? Let's see if it works. There's negative 12 and there's positive 1. So do I get negative 11x? Okay, so that did factor. So when you wrote f divided by g, you actually had to simplify it down to x minus 4. And then this one, I'm not going to times it out if that's all right. That's good. But the domain of this f and g are all real numbers, so the domain of this one should be all real numbers. This one is not all real numbers because on this one the domain is the domain of both of them, but you can't have the bottom, the denominator of this equals 0. So it's all real numbers except what? Negative 1/3, right? If you set this equal to 0, you get negative 1/3. So you can't have negative 1/3. So you might have to write it in interval notation, like negative infinity up to negative 1/3, union with negative 1/3 to infinity. Either way, you have to be able to write that. Okay. The other times that they're not all real numbers is if you have like a square root. So Zach, you asked that. Do I have the square root of something? And it's not going to be all real numbers either.
Okay.
So we are going to look at, let's look at one of those first. If I had like that, if I want to know the domain of this function right here, you have to have x plus 1 be positive. You can't take the square root of a negative or you get imaginary. So the best thing that I like to do is just look under here and just say, okay, x plus 1 has to be greater than 0. So x has to be greater than negative 1. So you have from negative 1 to infinity. It can equal 0 though. Like if you plug in negative 1, you can take the square root of 0, it's just 0. But if I did one a little bit different, so let's do find the domain of that one. Square root of 5 minus 2x. It's a little bit more complicated to find the domain of that. Sometimes you can just look at it and think, but that one's, you have to do more than just look at it. So if that has to be positive, you got to remember how to solve inequalities. How do you solve them? Would you guys get the 2 on the other side or leave it and then the 5? What would you do? Move the 5? So negative 2x greater than or equal to negative 5. What happens when I divide by negative 2? So yeah, it changes the sign, so it's everything less than 2.5. So it would be from negative infinity up to 2.5. Okay, so you guys might be using that in the next couple days, just the fact where the domain is on the square roots. Which, this is the same as one of these. Is it the G being plugged into the F or the F being plugged into the G? You know? Yeah, they stay in the same order. This is saying, if you ever see this with an open circle, so don't get it confused with multiplication, it means that the function G, you're plugging it into the function F.
So O stands for F. I mean O of.
Oh, is that what you think of it as? If the open circle is standing as an O, like G of F of X. And that, yeah, that's how you say it. This one you say F of G of X. Kind of like instead of saying F of X, you say F of G of X. So this one stays in the same order. You plug F into G. So that one is. So if I'm going to do that, remember that if I have like F, I'm going to, well, let me do H. If I have like, I don't know what the difference is, H of X equals 2x plus 1. If I want to find H of 3, that just means I plug in 3 in, right? 2 times 3 plus 1. If I have H of A, that just means I plug in A. 2 times A plus 1. If I have H of M plus 3, that just means I plug in M plus 3. So this is just saying everywhere there's an X, I put in M plus 3. So this would be 2, plug in M plus 3 plus 1. Okay, so whatever is inside the parentheses here, that's always, whatever's right inside there, that's what you plug in right there for X. So wherever that is, that's where you plug it in. So looking at that, I want you guys to see if you can figure out. Now, don't simplify it all out. Just figure out how to plug it in, what it is. I want you to see if you can write what f of g of x is, not simplify, just write it out, just the very first step. So everyone see if you can look at that. Okay, so f of x just says whatever you're going to plug in here, you've got to plug it in right here and right here. Right? So if I'm plugging in g of x, so I'm plugging in 2x minus 3, then everywhere you see an x, you've got to just put parentheses and plug in 2x minus 3. So it replaces the x. So don't get confused and think the x is still there. I plug it in right here. Here's 2x minus 3. Because it goes x squared plus 4. So there's my plus 4. Then I plug in another, whatever I'm plugging in. 2x minus 3. And then the last thing right here says subtract 1. So over here you would subtract 1. So now, of course, I'd have to simplify that all out. But that's the gist of it. Because now you would have to figure out what 2x minus 3 times 2x minus 3 is. So it's squared. You have to times that out. And then plus, or you times this out, 8x minus 12 minus 1. So I'm not going to do it. But I know you guys know how to do that. It's just the concept of getting to that. So now I want you to be thinking of g of f of x. So the function g, look at the function g, see if you can figure out what g of f of x is. And you don't have to simplify it out, just plug it in and see if you can find it. Okay, so I'm plugging in that right there, that's f, and I'm going to plug it in right here. And I would just times it out, subtract 3. I guess we can times that out fast, right? So just be 2x squared plus 8x. So it'd be minus 2, but then I have a minus 3 right here. Minus 5. Okay. The hard part comes from the domain and range of the g of f of x and f of g of x. Domain of g. So g is the line. What's the domain of g? What's the domain of a line? The x values of a line. Okay, negative infinity to infinity. So all those x values, and then we get a range out. We get the range of g out. So what's the range of g? Yeah, all real numbers, right? So I can plug in, this is saying I can now plug in any real number into f. So what is the range of f? So the range of f, not the domain, but the y values of f. So it's a parabola, so it's not going to have a domain of all real numbers. We got to remember how to find the range of a parabola. So a parabola looks like this. Is this one opening up or down on f? Up. I need to be able to find the range, the y values. So it goes all the way to infinity, but where does that y value start? How do you find the vertex? Yeah, go back to last year. Ask your secondary 2 student. You guys remember negative b over 2a?
Yes.
That's the x-coordinate of the vertex. So the x-coordinate of the vertex is negative 4 over 2 times 1. So negative 4 over 2.
Negative 2.
Negative 2. And then what do you get when you plug in negative 2? That's going to be your y value. Negative 5?
Okay.
4 minus 8 minus 1? Negative 5? Okay, so the range of f is negative 5 up to infinity. So if I want the domain of f of g of x, I can plug in anything into this. Just just like I can plug in anything into here, and the range of this is everything. So I'm good there, and then the range of it is going to be from -5 to infinity. And, yeah.
Would it be including infinity or?
Oh, sorry, I didn't even put that on there.
That's fine. I was just confused.
Yeah, exactly. But not that. Okay, let's look at this next one, because you have a couple like this on your homework, and they're kind of the confusing ones with the square roots. Okay, so range 1 to infinity right here. Now 1, I get square root of 3. Is everything else going to be bigger than that? If I plug in 2, 3, 4, are they all bigger than the square root of 3? Yeah. So this one just goes from the square root of 3 to infinity. Just because of the way it worked, because it went just from there, it just kept going up. So the domain of this one, domain is the same as that one, all real numbers, range from square root of 3 to infinity. Weird, but it's confusing, huh? Well, and what was the normal range of g of x? So you could plug in what? The domain would be, you could plug in -2 would be the smallest number you could plug in. And then what would you get out when you plugged in -2? 0. Because this graph, I don't know if you guys remember, so the graphs of the square roots look like this. And where does that one shift? If it's the square root of x plus 2, where does the plus 2 shift it? So this one looks like this. So normally, the domain would be from -2 to infinity, and the range would be from 0 to infinity. But you can't plug in anything until you get up to 1, because there's only 1 and above comes out. That's the only things you could ever get out of that. So that's why it started at the square root of 3 to infinity. So it's only starting at this point right here, which is the square root of, is 1 square root of 3. So that's why that only goes that far. And if we graph this, it makes sense too if we look at it. Now sometimes it's not going to work out perfectly with this, but if we wanted to look at that graph, do you want us to look at what the graph looks like? Maybe? We haven't ever looked at the square root of x squared plus 3. That kind of looks weird. Should we see what it looks like? Okay, so we decided our domain was all real numbers. This is looking kind of weird. Did I close my parentheses? Did I not put a parentheses in?
I don't know, that looks an opposite value.
It looks like kind of like a parabola too, and an opposite value both, right? So yeah, that's kind of a weird one. Looks like opposite value, maybe a little bit curved at the bottom. Should we see if the minimum is the square root of 3, see if we were right? Oh, sure. Second, calculate minimum.
What's the square root of
Oh, phew. Square root of 3, 1.7. It is square root of 3. Okay. Let's look at the other one, because the domain and range are what's the confusing part. It's hard. If I do g of f of x, g of f of x. So see if you guys can write that one. Figure out what g of f of x is. Write it down. See what that is. Okay, f of g of x. plugging in square root of x plus 2. X, you're plugging in g, so you take f, you plug in square root of x plus 2. So my function f says I square it and I add 1. So when I plug it in, square root of x plus 2, I square that and I add 1, which is, what happens when I square square root? X plus 2 plus 1. So it's just x plus 3 when you get done. Now the hard thing is it may not be the whole line. You think it's just the line x plus 3, but we've got to double check the domain and range. Because what could I originally, so kind of going back up here, but we'll do it the opposite. What can I plug in to this function? I can only plug in things that will work into g of x. So this has to be the domain of g of x. That's the only things I can plug in. Is the domain of g of x all real numbers? If I have a square root, is the domain all real numbers? Can I plug in every number into here? I have to plug in x plus 2 has to be greater than or equal to 0. So what numbers can I plug in? So this one I can plug in negative 2 to infinity. That's the only numbers I can plug in. And so if I'm plugging those numbers in, what numbers am I getting out? So this is g of x right here. What numbers am I getting out in g of x? When I plug in negative 2 to infinity. So we looked at the graph already, right? It looks like this. What y values do I get out? 0 to infinity, right? I can plug in negative 2, I get out 0. And then anything bigger I plug in. Sorry, this should be a bracket. 0 to infinity. Okay, so I can get out 0 to infinity. Now, the only thing I'm plugging in to f now, I can only plug in numbers from 0 to infinity. I can't get any other numbers because I can plug in negative 2 to infinity. I get out 0 to infinity. When I plug in from 0 to infinity, what kind of numbers am I getting out? This is what I'm going to end up plugging it into, where it's coming out of that. What happens when I plug in on x plus 3, so I have this line right here, I can only plug in from 0 to infinity. What does that look like? So I plug in 0, I get 3, and I can't plug in any of these numbers. And you guys know what this line looks like, right? 1x plus 3, just looks like that. So what numbers am I getting out when I plug it into here? Okay, and they start at what positive number? What's the very first one I get out? The smallest one I get out? 3 to infinity. So just kind of look at that every time. Think of what you're plugging in. Think of your x that you're plugging in. So kind of look on the inside, see what this can be, see what this will be, and then based on that, see what the next one will be. And that'll be, this will be your domain of your function, of this function, and this one will be your range of this function. You gotta just kind of see what you get as you plug it in. And we can work on some of those again later too. Okay, so here's one, and this one is just saying you don't have, you can find f of g of x, so you can find it and then plug it in, or you can plug it in another way. So if you guys were asked this question, f of g of negative 3, that question and this question are the same one, although there are two totally separate ways. Sorry, I need to put a negative 3 in here. There are two separate ways to do it. You can either plug negative 3 into the function f of g of x, or you can plug negative 3 into g, and then take that and plug it into f. So you kind of have your choice. I prefer to realize that this is this, plug it into this. Because could you guys, someone tell me bad. What is f of g of x in terms of x? F of, what is g of x? X squared. What's f of x squared? Here's f of x. F of x squared is x squared minus 5. You just plug it in right there. So I could plug in -3 right now, because that's what f of g of x is. So I could just go -3 squared minus 5. 9 minus 5, 4. That's one way to do it. So you have to find out what the function is and plug it in. Or I could find what g of -3 is. So what's g of -3? -3 squared, 9. Right? So when I want to find f of, this is just 9, I just plug in 9 into f. 9 minus 5. 4. So I guess it depends on how complicated it is to find this function, which way you will prefer to do. But you just either plug it into the inside function, find the answer, plug it into the outside function, or find the composition and then plug it in. Okay, so you're getting composition, plugging in function into each other. Okay, here's, okay, read this one. Find f of x and g of x such that h of x equals the composition of the two. And you know it actually gives you g of x. So really, the question is, what is f of x? So look at this for a minute. And if you know g of x is x plus 1, try to find f of x so that that is true. Okay, so you guys see that this x plus 1 is plugged in right here and right here. So what does f of x need to be so that it plugs in right there? Yeah, the plain f of x would just be that. 2x squared minus 3x minus 5. So you just got to be able to kind of see them and find some that go together. To see 2 something squared minus 3 something minus 5. Okay, let's look back at this one. And I want to take the 15% discount first. What am I going to pay if I do the 15% discount first? How much do you pay if you take off 15% off of 100? $85, right? And then I take off 20%. What is 20% off of 85? Are you guys going to figure out 20%? Can you figure out 20% fast?
Yeah.
Can you figure out 10% fast? Probably. Yeah, 8.5, 850. So 20% is twice that. 17. So what is 85 minus 17? 68. So if you do the 15%, then the 20%, it's 68. But if you do the 20%, then the 15%, what's 20% off? 80. And then 15% off. What's 15% of 80?
12.
66.
Wow. Oh, so then you already subtracted it? So remember, to find 15%, like if you ever go out and you want to give your waitress a 15% tip, find 10%. What's 10% of 80? 8. And then do 5% half of that. So 4, so 12. $12 off.
68.
So they ended up being the same. I didn't think they were going to be the same. But yeah, if you times it by 85% and then times it by whatever, you're still times it, doesn't matter the order you times it